Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Hamdan and I am from Group 9, which is I am going to represent to you about Phylum, Porifera and Cnidaria. And my other members group name is Naufal Hakim bin Nazri and Muhammad Aiman bin Anwar. So let's proceed to the next one. Okay, first one is the introduction of Porifera and Cnidaria. Porifera and Cnidaria are organisms which share similar characteristics with one another, and both of these species are living in the sea, and they are both multicellular and they consist of many cells working together. And then they are both eukaryotic, which is they have DNA in the form of chromosome contained within a distinct nucleus. Also, they are both heterotrophic and they ingest other organic material, and they also can both be found in similar marine environments, which is in the water. And we can see that from here, Porifera is like kind of a sponge, and Cnidaria is like jellyfish. So we go to the next one. Next, the taxonomy chart of Porifera and Cnidaria. Okay, for the domain, for this Porifera and Cnidaria, it is called Eukarya. And for the kingdom of Porifera and Cnidaria are called Animalia. And the phylum is called by their names, which is Phylum, Porifera and Cnidaria. And for the subphylum, it is called subphylum Symplasma, and the Symplasma is divided into the three classes, which is the first one class Calcaria, and the second one is class Hexatenella or Triaxonida, and the third class, which is Demospongia. So for the Calcaria, it is divided into the two orders, which is the first one Homocoela, and the example is Clatrina, and the second one is Heterocoela, and the example of Heterocoela is the Cycon. And for the Hexatenella or Triaxonida, they're having two orders, which is the first one Hexasterophora, and the example is Euplectella, and the second one is Amphidiscophora, and example of Amphidiscophora is Hyalonema. And the third classes, which is Demospongia, is divided into the three orders, which is Choristida, and the example of it is Anchorina, and the second one of the Spongia, the orders, which is Halichondrina, and the example of it is Halichondria. And the third one, the last one of the orders for the Spongia is Haplosclerina, and the example of the Haplosclerina is Spongilla. So we go to the next one. Next one is the application of Phylum, Porifera and Cnidaria in life. This is the application of Phylum, Porifera. Okay. Porifera skeletons were once used as a washing sponge. We can use it in our daily life, and these sponges are very popular in the health and beauty field, which is we can see that these sponges are used to cleaning an array of surfaces and have better water retention than that of the artificial sponge. Most popular use include car wear, which is we can see that most of the people use sponge to wash the car, to do the skincare routine and makeup application and removal, and also skin exfoliant for when bathing and personal care. This we can conclude that sea sponges are very important to the application to the human. If taken care of properly, they can last year on end, where an artificial sponge can fall apart and be riddled with bacteria after months of use. More than that, dolphins, not also humans, use this sponge, but also Animals, which is dolphins, also will use marine sponge to protect themselves while searching for food. Sponges also serve as a protection mechanism for scallops. The sponges will attach and live on the shell and protect it from organisms such as starfish, which can damage it. Next, this is an example, which is the figure, which is we can see that here, figure 5, a freshly harvested wool sponge. And this is the figure 6. It's example of how a wool sponge is implemented in a bar of soap for the use, for the application for the humans in our life. So next we go to the application of Cnidaria in our life. Cnidarians are like some edible species of jellyfish, are suitable for human consumption and are used as a source food. We can see that a human also make Cnidarians, which is jellyfish, as a food and as an ingredient in various dishes. All kinds of coral, hard and soft, sea animals and other Cnidaria are extensively harvested from the whale for the leaf aquarium trade. Hard coral are also mined as building materials in some coastal areas. Then, reefs bring in tourists which generate business beyond the shore, which is reefs are used in the hotels, restaurants, and travel-related industries. Reefs are also homes to be wandering a variety of creatures, some of which protect themselves with toxins or other chemicals that may have pharmaceutical applications. This is an example of the coral reef. Next, and this is the application of Cnidaria in protecting small fish using sting. Let's watch the video.
You're swimming in the ocean when something brushes your leg. When the tingling sets in, you realize you've been stung by a jellyfish. How do these beautiful gelatinous creatures pack such a painful punch? Jellyfish are soft because they are 95% water and are mostly made of a translucent gel-like substance called mesoglia. With such delicate bodies, they rely on thousands of venom-containing stinging cells called cnidocytes for protection and prey capture. Even baby jellyfish, the size of a pencil eraser, have the ability to sting. Larval jellyfish, ephyrae, look like tiny flowers pulsating in the sea. As they grow, they become umbrella-shaped with the bell at the top and descending tentacles around the margin. The largest species of jellyfish, the lion's mane, has tentacles that can extend more than 100 feet, longer than a blue whale. These tentacles contain most of the stinging cells, although some species have them on their bells too. Venom is ejected via a nematocyst, a whip-like hollow tubule, which lies coiled under high osmotic pressure. When mechanical or chemical stimuli activate an external trigger, the lid of the cell pops open and seawater rushes in. This forces a microscopic barbed harpoon to shoot out, penetrate and inject venom into its victim. Nematocyst discharge can occur in less than a millionth of a second, making it one of nature's fastest biomechanical processes. Nematocysts can continue to fire even after a jellyfish has died, so it's important to remove lingering tentacles stuck to the skin. Rinsing with vinegar will usually render undischarged nematocysts inactive. Seawater can also help remove residual nematocysts, but don't use fresh water, because any change in salt balance alters the osmotic pressure outside of the cnidocyte and will trigger the nematocyst to fire. That's why urinating on the affected area, a common folk remedy, may do more harm than good depending on the composition of the urine. Most jellyfish stings are a painful nuisance, but some can be deadly. An Indo-Pacific box jelly, also called a sea wasp, releases venom which can cause contraction of the heart muscles and rapid death in large doses. There's an anti-venom, but the venom is fast-acting, so you need immediate medical intervention. Despite the impressive power in their tentacles, jellies aren't invincible. Their stinging cells are no match for the armor of thick-skinned predators like the leatherback turtle and ocean sunfish. These predators both have adaptations that prevent slippery jellyfish from escaping after they are engulfed. Backwards pointing spines in the turtle's mouth and esophagus, and recurved teeth behind the sunfish's cheeks. Even tiny slipper lobster larvae can cling to the bell of a jellyfish and hitch a ride, snacking on the jelly while they preserve their own energy for growth. Small agile fish use the jellies as moving reefs for protection, darting between tentacles without ever touching them. Nudibranchs, which are sea slugs covered in protective slime, can actually steal the jelly's defenses by eating the cnidocytes and transferring them to specialized sacs for later use, as weapons against their own predators. Even humans might benefit from the sting of a jellyfish one day. Scientists are working on manipulating cnidocytes to deliver medicine, with nematocysts rarely 3% of the size of a typical syringe needle. So, the next time you're out in the ocean, be careful, but also take a second to marvel at its wonders.
So we go to the next one, which is the application of the Cnidaria. Okay, Cnidarians use their cyanides to trap prey items, and Cnidaria also protect the small fish from being eaten by predators with their stinging cells. And other than that, Cnidaria boosts the fishing, recreational, and tourism a lot. And Cnidarians also are a few sources of new medicines, which is the new medicine is by making drugs and useful for organic farming practices. Next, this is the reference for the ayatization Quranic verse or Islamic perspective. It is وَجَعَلْنَا مِنَ الْمَاءِ كُلِّ شَيْءٍ حَيٍّ. We have made from water every living thing. This shows that Phylum, Porifera, and Cnidaria are the creations by Allah subhanahu wa ta'ala in the water. And this is the references for my groups. And that is all from us. Thank you.